Okay, so definition. So let's let f of theta be equal to either a cosine of the quantity n theta plus c plus d, or let's have that f of theta is a times sine of the quantity n theta plus c plus d. That's a d, not a b. D. Then, number 1, the amplitude. Of course, we know this, but it's always good to refresh. So the amplitude will be the absolute value of the coefficient. Remember, it's distance. So let me underline amplitude. The period, which we're calling capital P, is 2 pi divided by the absolute value of n. Number 3, the phase shift. So here's a new definition. Phase shift. We're going to call that phi. And that's going to be the negation of c over n. And remember, that is the horizontal translation. So this is left slash right. And last but not least, the vertical transformation, or the vertical shift. It's just going to be d, simply. So basically, we're combining everything together, horizontal and vertical shifts. So let's do this. Let's plot a couple of these. So for example, let's plot the graphs of the following functions. So plot the graphs of the following functions. So number 1, let's plot the graph of f of theta is equal to, shall I do 3? That's a big amplitude, but okay. 3 times sine of the quantity, 5 theta minus pi over 2, from which to which I'll add 1. Okay, so let me recap this. We have that f of theta is 3 times sine of the quantity, 5 theta minus pi over 2, and we're adding 1 on the outside. So I'm going to first factor out the coefficient of theta inside the parentheses. So 5 times the quantity, theta minus pi over 10 plus 1. Okay, so let's analyze this. The amplitude is the coefficient 3 in front. The period, P, is still 2 pi divided by the coefficient of theta, which is 5. So now the phase shift phi is going to be the negation of negative pi over 10. So that is, it's pi over 10. Or I can just say it's counterintuitive, because I know the phase shift corresponds to horizontal translation. So that's basically right, pi over 10 units. But now we have the vertical translation. What color shall I use for that? Eeny, meeny, miny, mo. Let's use red. So the vertical translation is up 1. Okay, so let's go ahead and plot all of this. So theta versus f of theta coordinate axes, and in this case, I have an amplitude of 3, so it's going to be rather tall. Do I have enough room there? Maybe I need to move that up 1. Okay, so theta versus f of theta. Let's do 1, 2, 3, 4. 1, 2, 3, 4, and amplitude of 1, 2, 3, going up to 4, 1, 2, 3. So 3, 4, 2, 1, negative 1, negative 2, negative 3. I know that this is going to be 2 pi divided by the coefficient. This is pi over 2 divided by the coefficient of theta, pi divided by the coefficient of theta, and 3 pi over 2 divided by the coefficient of theta, which in this case is 5. Okay, so this corresponds going backward to minus pi over 10, negative pi over 5, negative 3 pi over 10, and negative 2 pi over 5. Okay, so it looks like I'll be moving everything right pi over 10 units, which is 1 quadrant. But prior to that, I'm going to plot without any translations. So sine usually starts at 0, goes up to amplitude when it's positive, back down to 0, down to negative amplitude, and back to 0, and has 180-degree rotational symmetry. So this is sine without any vertical or horizontal translations. Okay, so first I need to shift everything to the right 1 quadrant. So if I shift everything to the right 1 quadrant, so that's my horizontal translation, my graph would look something like so. But finally, I need to shift everything up 1 unit. So that shift is now up 1 unit. Oh, not 1.5, 1. So everything gets shifted up 1 unit from where it is after the horizontal shift. So finally, the graph of sine with an amplitude of 3 that has been shifted to the right pi over 10 and then up 1 unit looks like so. Oh, that doesn't look very good. Let's see if I can make that a bit better. I'm trying. Okay, so there we are. I know it looks a bit chaotic. Sorry about that, but I hope you can follow what I'm doing. So let's do a couple more examples. Let's see, do I have space here? Yeah, I do. So let's do another example. So for example, or actually, I think it's subscript number 2. Yes, I'll make this subscript number 2. So we have that f of theta. Let's plot 1/2 cosine of the quantity. Let's do 4 theta plus 3 pi over 2 minus 1. Okay, so we have f of theta is equal to 1/2 cosine of the quantity 4 theta plus 3 pi over 2, quantity minus 1. So I'm going to factor out the coefficient of theta. That is 4. So what remains is theta plus 3 pi over 8. Okay, so what do I have? I have that the amplitude is 1/2. I have that the period is 2 pi divided by 4. I have that the horizontal translation, or phase shift phi, I know it's counterintuitive because it's horizontal, so this will be minus 3 pi over 8 because it's left, right? So it's counterintuitive, so the negation of what's inside there. And finally, I did this in red. My vertical translation is going to be down 1. Okay, so let's go ahead and plot cosine with all of these requirements. So theta versus f of theta coordinate axes. So theta and f of theta. We have 1, 2, 3, 4 quadrants. 1, 2, 3, 4 quadrants. Let's do 1, 1, 1. Okay, so my 4 quadrants is 2 pi, but I'm going to divide that by the coefficient, which is 4. So I'm taking all of my quadrants, dividing them by the coefficient of theta. So divide by 4, divide by 4, divide by 4, divide by 4. So this corresponds to negative pi over 8, negative pi over 4, negative 3 pi over 8. Okay, that's interesting. And negative pi over 2. Because when I notice that I'm going left 3 pi over 8, that means everything is going to shift 3 quadrants left. Okay, so this is 1. So 1/2 will be in the middle, negative 1, negative 2. Okay, so normally what would cosine look like? Cosine would start at amplitude, which in this case is 1/2, and would be symmetric on either side with respect to the y-axis. So it would look something like so. Oh boy, that doesn't look very good. So it's a very shallow graph because it only has an amplitude of 1/2. Okay, but let's go ahead and shift this left 3 pi over 8. So everything is moving to the left 3 quadrants. So starting on the rightmost point here, goes left 1, 2, 3, then goes down, down, up, up, down, and I can just follow that. So down, down. So what happens is we get this next graph. So notice going to the left 3 quadrants looks like it's equivalent to moving right 1 quadrant, right? Okay, and finally, let's move all of those points down. Maybe I'll do this. What color should I use? Okay, dark blue and light blue. So now everything is shifted down 1 unit. So this point that's here on the axis is shifted to negative 1. This point here at positive 1/2 is now negative 1/2. And I follow each point down 1 whole unit. So finally, we get the graph of cosine with an amplitude of 1/2. Shifted 3 quadrants left. And 1 unit down. Looks something like so. So let's note something about the range here. The range is now from negative 1.5 to negative 1/2, right? So from negative 3/2 to negative 1/2. And that's it. Did I do the same thing here? I did not. So maybe I should have looked at the range for this function up here. So the range for this function up here went from -2 to +4. And the domain, of course, is all real numbers, so let me be thorough. The domain is no restrictions for theta. Same thing here, the domain, no restrictions for theta. Okay, so one more for good measure. So subscript number 3, let's plot the graph of f of theta is equal to, let's do 2 cosecant of the quantity 2 theta minus pi plus 2. Okay, so we have that f of theta is going to be 2 times cosecant of the quantity 2 theta minus pi plus 2. First thing I'd like to do is factor out the coefficient of theta. So this will be 2 cosecant of 2 times the quantity theta minus pi over 2 plus 2. So I'm going to consider g of theta equal to 2 sine of the quantity 2 theta minus pi over 2 plus 2. So what is the amplitude here? Well, the amplitude is 2. Let me actually write that in orange. The period, of course, will be 2 pi divided by the coefficient of theta, which is still 2. The phase shift, phi, so it's counterintuitive, so that's going to be positive or right pi over 2 units. And last but not least, I'm going up 2. Okay, so first I need to use sine to plot cosecant. So theta versus f of theta coordinate axes. And I know these are terrible representations of theta. Let me make that look a bit better. So 1, 2, 3, 4 quadrants going right. 1, 2, 3, 4 quadrants going left. I have an amplitude of 2. So 1, 2, 3, 4, because I know I'm moving up 2. Sorry, -1, -2. Okay, so 4 quadrants is 2 pi divided by 2. So pi over 2 divided by 2, pi divided by 2, and 3 pi over 2 divided by the coefficient of theta, 2. So this corresponds to negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. So notice that I'm going to the right pi over 2 units, so that's 2 quadrants. Okay, so 3 steps here. Hopefully I have enough colors. So sine would usually start at 0, go up to amplitude, back down to 0, down to negative amplitude, and back to 0 for the quadrantal angles, and is symmetric with respect to the origin. That is, it has 180-degree rotational symmetry. So this is sine, not cosecant, prior to any translations. Okay, so now let's move the graph of sine, not cosecant. Let's shift the graph pi over 2 units to the right, so everything is shifted to the right 2 units, or 2 quadrants rather, which in effect looks like it's the negation or the reflection about the x-axis of sine. Maybe I'll make that a bit darker. Okay, and now we want our vertical shift upwards. So what color should I use for that? This one. So now I'm shifting everything up 2 units. So each point I have here that has already been shifted to the right 2 quadrants is now going to be shifted up vertically 2 units. Okay, but remember, vertical shift doesn't change the asymptotes. So the asymptotes are where, after the horizontal shift, I intersected the x-axis. Oops. Okay, so the last graph of sine is what I'm going to use as my guide for the graph of cosecant. So the darkest graph here will meet at the peaks and the troughs of that darkest graph, and will go off asymptotically towards the asymptotes. So notice there would have been another one here had I plotted it. Okay, kind of a bit of chaos, but if you're watching me do the video, hopefully that will help. Okay, so the domain, of course, for any reciprocal function has to exclude those values of theta where I have asymptotes. So that's after the horizontal translation. So it looks like it can't be pi over 2 plus any integer multiple of, plus it's just pi over 2k. Okay, so where k is an integer. Okay, those are the guys I need to exclude there. Let's look at the range. The range looks like it goes from 0 all the way downward, then starts again up at 4 and goes all the way upward. So that is, I start from minus infinite, go to 0 inclusive, because I can actually get there. Then I start again at 4, and I go off towards positive infinite.